Okay, so now we're going to do an experiment that you have probably heard before, the gummy bear explosion. So what we're gonna do to this poor gummy bear, okay, and I chose the green one. We're gonna see what happens when we mix it with a compound that is called potassium chlorate. This potassium chlorate has, of course, potassium, it has chlorine, and it has oxygen. The first thing that I'm gonna do, this is actually potassium chlorate, is a white powder. And the first thing that I'm gonna do is try to melt it. So I have a flame right here, and we're gonna see how let me actually put my hood in here. I'm gonna try to melt it as best as we can. So once we melt it, you're gonna see that it's going to turn into a liquid. That's the process of melting, adding heat. So I'm adding energy to this to melt this potassium chloride. And you can see how it's already turning into liquid. Hopefully you can see that. But we have a lot. We have about 5 grams. And you can see that I am trying to heat evenly everywhere to make sure that it all melts together. Okay, so now I'm outside the hood, and let's see what happens when I dropped. And I'm gonna use my hands because yesterday I tried with the tongs and they kind of like get stuck in the tongs. So I'm just gonna do this. Whoa, look at that. Oh my goodness, let me turn on the hood because we're involving a lot of gas. Whoa, look at what happens over there. Okay, that gummy bear is gone. Okay, so you see the flame inside? That flame inside is purple. That purple color comes from the potassium. Potassium tends to, when we burn potassium with a flame, you see a flame that is purple. Oh, look at that. Poor gummy bear. Now, what actually happened here? Remember that I said that we had that potassium chlorate that had potassium, chlorine, and oxygen. When we heated that, it melted, and we had to actually add some energy. Okay, so that means that it's what we call an endothermic process because we need to add energy to melt it. That potassium chlorate got into, with that energy that we also kept adding because we still have heat. What it did is that it split up in potassium chloride that has only potassium and chlorine, and then oxygen, O2. Now what happens when you add oxygen to something that has carbon and hydrogen, and even oxygen like the gummy bear? This is exactly what happens. So what we actually did is that we went from an endothermic reaction to an exothermic, something that generated a lot of energy, and that's what we saw when it exploded. The gummy bear has sugar. Sugar is made out of carbon, hydrogen, and oxygen. And that's when we burn fuels. When you think about any fuel, the fuel that you put in your car or someone puts in their car, they have carbon and hydrogen. This sugar has carbon, hydrogen, and oxygen. When it combines with oxygen, that's called a combustion reaction. And a combustion reaction always gives you carbon dioxide, which is what we exhale when we breathe. It gives water, and then a large amount of energy. And that's the energy that we saw. This is absolutely awesome. So let me see, we can see how it actually looks from the inside. Let me fix this safe now. Ooh, it smells really burnt. But you can see how it looks inside. And I'm going to show you, okay? I'm gonna go over here. This is what I did yesterday, was another gummy bear, and poor gummy bear. So what we have right here is all this black. This is carbon that was left from that gummy bear. Remember, sugar has carbon, hydrogen, and oxygen. And that carbon was left over, a little bit of left over. This white is just the potassium chloride that was left, that was actually made. And no sign of the gummy bear. The color means nothing, although maybe you can see what color was the gummy bear that I used yesterday. It's a red one. I wonder if the one that we have here, I'm gonna go back and see if, well, yeah, we can't see anything yet. But maybe what we will see is that the color of green maybe remains. So this is actually pretty cool. Unfortunately, you cannot do this at home, but that is really nice to do it in the lab. So if you take a chemistry course and your teacher has a hood like the one that I have here, you can see that in my hood. It's really fun. Okay, so I hope that you enjoy it, and I'll see you in the next video. So what I've done now, I actually have a bigger test tube. Okay, I'm gonna show you right here, a bigger test tube. I put about double the amount of potassium chlorate, but now I'm going to use a different kind of gelatin sugary treat, and that's what I had to use something bigger, because I'm going to use Swedish fish. So let's see how this one works. I'll make sure that I have my gas off, and let's drop it and see what happens. Whoa, okay. Ooh. So it looks like it's exactly the same, except a little bit more intense. And that doesn't have to do with the type of treat that we're using. It's just because we have more of the potassium chlorate, therefore I produce more oxygen when I melted it. And then the fish, the Swedish fish, is bigger in size, so it has more mass, and therefore it contains more sugar. So what we saw is, again, more intense, and there's a lot of smoke inside the hood. You can see that there's still some smoke there. It's still a combustion reaction. I'm gonna wait a little bit and see that, make sure that that smoke is subsiding, and then we'll see how the test tube looks inside. Let's see, I really can see a little bit from here. There you go. And of course, I have the hood on to make sure that all those gases do not come towards me. Okay, and let's see. Turn this off. It was pretty dark in there, and definitely the fish is gone. Oh, it smells, actually this one smells delicious. It smells like burnt sugar. Okay, because again we have the sugar and the oxygen, combustion reaction, carbon dioxide, water as a product, and a lot of energy, exothermic reaction. Okay, and in a little bit I'm gonna see how this fish